So still exercises and functions, part 2. So let's say we're given f of x equals square root of x minus 1 raised to 4, x plus 3, 3 minus x all over 4x plus 1, x minus 7, x plus 5 raised to 11. We are asked to find the domain of f. To get the domain of this, so we have to take note of the nature of the function involved. This is square root. And we know that if it is square root, we do not want the radicand to be what? To be less than 0. Am I right? So meaning, we want our x minus 1 raised to 4, x plus 3, 3 minus x, all over 4x plus 1, x minus 7, x plus 5 raised to 11 to be greater than or equal to 0. Am I right, guys? Now, determine the solution set of this rational inequality. First, we need to determine the critical numbers. No? Critical numbers are the zeros of the numerator and zeros of the denominator. So for the numerator, what are the zeros, guys? X is equal to 1, -3, +3, right? What about the denominator? What are the zeros of the denominator? -1/4, +7, -5. Am I correct, guys? The zeros of the numerator are parts of the solution set, no? While the zeros of the denominator are not, okay? Because these numbers will make the denominator 0, not parts of solution set. Is that clear, guys? Guys.
Yes po.
So, and then we're going to prepare a sign table or a sign chart to determine in what interval the sign of each factor is negative. No? We're going to arrange these critical numbers on a number line. So this is our number line x. Going to the right is positive infinity. Going to the left, negative infinity. And then the smallest number is -5, no? Then the next number to it, greater than that. So -3, followed by -1/4. Then we have +1, right? Then 3. The last one, 7. So we have arranged the critical numbers on a number line from lowest to highest. And then after that, we list down all what? All the factors involved in the numerator and in the denominator. X minus 1 raised to 4, x plus 3, 3 minus x. In the denominator, 4x plus 1, x minus 7, x plus 5 raised to what? To 11. Huh? Take note that 1, -3, and +3 are in the solution set. No? So -5, -1/4, and 7 are not. Now, you have to determine where each expression listed here is becoming 0, no? X minus 1 raised to 4 is 0 when X is what? When X is 1, meaning it's neither negative nor positive when X is 1, okay? So what about X plus 3? It is 0 when X is negative 3, right? What about 3 minus X? When X is 3, or X plus 1, when X is negative 1/4, X minus 7, when X is 7, X plus 5 raised to 11, when X is negative 5. Okay? Now, let's now have the signs of each expression in every interval. Now, to the right of 0, so this expression is always positive, right, guys? Because it is raised to 4. And even to the left of 0, it is always positive. Am I correct, guys? Because it is what? Raised to 4. Whatever number you enter or input to X, in every interval that we have here, this is always positive. Okay, children? And actually, any number to the left of 1 and to the right of 1, this expression is always positive. What about X plus 3? X plus 3 is always positive to the right of negative 3. Am I correct? Guys?
Opo.
And then to the left, negative. What about 3 minus X? Where is 3 minus X negative? To the right or to the left? Guys? Where is 3 minus X negative? To the right of 3 or to the left of 3? Where is it negative? To the right, no? Because the coefficient is negative, the coefficient of the variable. Okay? So if you try to assign a number, as long as to the left, to the left of 3 positive, to the right negative. So again, if you assign a number to the left of 3, this is always positive. To the right, this is always negative. Okay? What about for X plus 1? Negative here, negative, negative. Positive to the right of 1/4. Negative, 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 negative. To the right of 7, positive. Negative here, to the right of negative 5, positive. So what are we going to do with these expressions? We are going to multiply the first 3 and divide to the product of the last 3, no? So for the quotient, we have quotient of this. So negative, negative, negative. How many? 1, 2, 3, 4. So positive. Am I right, guys? 1, 2, 3. So this is negative. How many negatives? 2. Therefore positive. Negative. Am I right? Negative, positive, negative. Is that correct, children? Guys? So we now have the following. We want it greater than or equal to 0. So we have the following intervals. Negative infinity to less than negative 5. And then we have from negative 3 to less than negative 1/4. Then include 1, no? We have to include 1 because 1 here is not included in any interval. So we have to include that in the what? In the domain, because this belongs to the solution set of this inequality. And then here, okay? From 3 to less than 7. So what is the domain, guys? Anyone? Guys? What is the domain of F, guys? Negative infinity to less than negative 5, right? Union with from negative 3 to less than 1/4. Union with the set containing 1 because 1 is part and it is not included in any of the interval. So we have from 3, union with from 3 2 less than 7. Would you please check my answer, guys? Is this correct, guys? Guys.
Yes,
Okay?
Master.
So that's the domain of f, which is the solution to this inequality. What about this number 2? Given f of x equals the absolute value of x plus 2 minus the absolute value of x minus 2. We are asked to find f as a piecewise defined function. Letter B, the graph of f, and then letter C, domain and range of this given function. Now, to get rid of the absolute value symbols, so first we define its absolute value in bold. The absolute value of x plus 2 is defined as a piecewise defined function given by negative x minus 2, meaning the negative of the inside, if x is what? If x is to the left of negative 2. Am I right, guys? And then it is x plus 2, we just copy if x is greater than or equal to negative 2. These two expressions are connected at x equals negative 2. Am I right? So the graph of this is connected at x equals negative 2. What about x minus 2, absolute value of that? For absolute value of x minus 2, this is equal to what, guys? It is, negate this one, x minus 2. What's the negation? 2 minus x if what? If x is less than 2, no? And it is x minus 2 if x is greater than or equal to 2. Get it, guys? Guys.
Yes.
Okay, so we are what? We are solving this, no? So this is what we want to express in a piecewise defined function. So given f of x is equal to, so letter A, absolute value of x plus 2 minus the absolute value of x minus 2. So the first absolute value is what? Equal to what, guys? Anyone? The first absolute value is equal to what? So the first interval that we're going to have, let us have a guide. I think the guide will help us. Let's determine the critical number of absolute value of x minus 2 minus the absolute value of x minus 2. So when we say critical number, the zero of x plus absolute value of x plus 2, it is 0 when x is what, guys? When is it 0, guys? When x is negative 2, no? What about absolute value of x minus 2 when x is 2? So meaning, the domain of this is subdivided into 3 subintervals or 3 subdomains. Okay? So this is, let's say, the number line x. When x is to the left of negative 2, how do we define the absolute value of x plus 2? So that is negative x minus 2. Am I right, guys? If x is to the left of negative 2, I am going to use this expression to what? To replace or replacing the absolute value of x plus 2. Then what about absolute value of x minus 2? If I am considering numbers to the left of negative 2, I'm going to use 2 minus x as a replacement to absolute value of x minus 2. Am I right, guys? Because if x is to the left of negative 2, it is covered here, no? Less than 2. So then minus 2 minus x, okay? So this is the first expression defining our f in a piecewise defined function, no? So that is if x less than negative 2, okay? So, by the way, we are trying to divide this interval into what? or the domain into 3 subintervals, no? We have negative infinity to negative 2, and then to less than negative 2, from negative 2 to positive 2. You can include the 2 in the next interval, 2 to positive infinity. Okay? You have an option to include these 2 in the middle interval. Okay, and negative 2, this negative 2 in the first interval if you want. Okay, guys? So the middle expression defining this f is what? So for the first absolute value, if x is between negative 2 and 2, so where is that? All numbers between negative 2 and 2 belongs where? I mean, belong to what? All numbers between negative 2 and 2 belong to what, guys? Greater than negative 2, right? So I'm going to use x plus 2. What about in the second absolute value? So where is negative 2 to between negative 2 and 2 interval belongs? So it belongs also to what? To less than 2, right? Guys? So minus 2 minus x. Am I correct, children?
Yes, sir.
So that is if x is between negative 2 and 2, including negative 2. Okay? So because that's what we have in this interval, no? But as I said, you can include the negative 2 if you want in the first interval. And then the last one, to the right of 2. So to the right of 2. So I am going to use x plus 2 in the first absolute value, no? Because we are having to the right of 2. So it is greater than negative 2, no? So then minus, what about the absolute value of x minus 2? To the right of 2, we have x minus 2. Clear, guys? So let's simplify this. So the first expression defining f of x is given by negative 4, no? So if x is to the left of negative 2, positive 2x, okay, guys? If x is between negative 2 and positive 2, including negative 2. And then the last one, it is simply positive 4, no? If x is to the right of 2, including 2. Okay? So this now, the piecewise defined function is equivalent to the given function of this is having absolute value symbols. This one does not contain absolute value but expressed in piecewise form. Okay, guys? Do you have any question here, guys? So this is letter A. So what about letter B? For letter B, we want to know the graph, no? Okay, guys? So how to know or how to determine the graph of F? So we have how many, guys? How many expressions defining F? We have one horizontal. So for the graph of F, y equals negative 4. This is horizontal line, but less than negative 2, no? Or x less than negative 2. Horizontal line. Okay, guys? Now, is it connected to the line representing 2x? Guys, between negative 2 and 2, including negative 2 here. When x is negative 2, 2 times negative 2 is negative 4, which is the same in this y equals negative 4. So it means y equals negative 4 is connected to 2x now, to y equals 2x. Okay, guys? So this is when x is between -2 and 2 including 2. This is a slant line, no? Slant. What about y equals 4? That is when x is greater than or equal to 2. Horizontal line also, that is above the x-axis, no? But the line starts from 2. Now, if x is 2, we have y is 4. In the middle expression defining f, if x is 2, it is equal to 4, right? So it means connected to the last line, no? This slant line is connected to this horizontal line. So we're now ready to draw the graph. This is the y-axis. Okay, so this is the x-axis. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -6, -3, +3, 4, 5, 6. Okay? And then here, 1, 2, 3, 4. 1, 2, 3, 4. Let's have up to -5, -5, -2, +5, +2. Okay, guys? When x is to the left of -2, we have y equals -4. So 1, 2, 3, 4. To the left of -2 is here. Am I right, guys?
Yes po.
Yeah. Okay, so this point. Okay, and then to the right of 2, 4. 1, 2, 3, 4. To the right of 2, solid point also, no, because connected to the slant line. Then to the right of, yeah. Okay, then the other one, 2x will pass through the origin between -2 and 2, no? So we just connect it here, passing through the origin, connecting also, or connected also here. Okay, that's the graph. Any question with the graph, guys? This is the graph of f of x is equal to the absolute value of x plus 2 minus the absolute value of x minus 2. Clear, guys?
Yes, sir.
Okay. What about the domain, guys? What about the domain? Obviously, the set of all real numbers, right? What about the range? From what? From -4 to +4, no? Am I right?
Opo.
Now, this shows that graphs are many times useful, no, in determining the range. Because if you did not draw the graph, it's hard to actually do mentally finding the range. Okay, guys? Yeah. So that's the range from -4 to +4. Do you have any question with this? Before we move to the next number?
None po.
Okay, let's have number 3. Given f of x equals sine of x, so this is sine function or signum function. I'm not really sure of my pronunciation. This is a Latin word. Is it sinu or signum? Just check, no? Google it. And then g of x is the greatest integer function. Are you familiar with these functions, guys? Guys?
Yes. Yes po.
Okay. So the first one, again, determines the sign of a number, x, no? If x is positive, so you have 1. If x is negative, you have -1 as the value of this function. If x is 0, neutral, neither negative nor positive, so it is 0, okay? And for the greatest integer function, this is the greatest integer that is less than or equal to x, no? Let's say if my number is 2, what's 2.5? What's the value? What is the greatest integer of that? Positive 2, right? If I have negative 2.5, it is -3. Am I correct? If it is 2, it's still 2. Okay? So that's how we define g of x, no? So again, to recall, sine function is given by this piecewise function. It is -1 if x is less than 0. It is 0 if x is 0. And it is 1 if x is greater than 0. Okay, guys? What about g of x? How do we define g of x, guys? This greatest integer of x. By the way, there are books having different symbols for greatest integer. Huh? So this is the symbol that we're going to use. How do we define this, guys? It is equal to what? In terms of piecewise, you can define that also. It is an integer n. It is always integer n. Okay? Where n is less than or equal to x, but x is less than n plus 1. For all n, that is what? Integer. Okay, guys? So for instance, if my x is 2.5, so what is that integer that includes x from the left, and another integer when you add 1 will include it from the right, no? So let's say my number is 2.5. What is that integer equal to 2.5 or less than 2.5, such that if I add 1 to it, it will include 2.5. So meaning 2.5 is in between. So that is 2 and what? Guys, 2 and 3, no? So meaning 2 plus 1. So our integer n is 2. Okay, guys? So 2.5 is between 2 and 3. And that n that is equal to or less than the x, which is 2.5, is what? Is 2. That is the integer. Okay? So we want integer as the value. So meaning we are pulling down the value to the next or to the lower integer. Is that clear, guys? Sometimes it is called floor function. So also called floor function. Pulling down the value. If I have 2.9, it will be pulled down to what? To positive 2. If I have 2, so that's still 2. You pulled it down to what? To the left, no? The value. Okay? So we're now ready to find the following values. So what is f of 3, guys? So what is the sign of 3? Children? 1, no? Positive 1, according to the definition of sine function. What about f of -2? Guys?
-1.
-1. What about f of 0?
0.
So it is 0. What about g of 2.5? What is g of 2.5? Meaning, what is the greatest integer of 2.5? Pull it down to the lower integer.
2.
2, no? So what about negative 2.9? What is the greatest integer of this, children?
-3.
Negative 3, no? Don't be confused, ha? Not negative 2. Because you pull it to the left, no? Negative 2. Sorry, it is negative 3. What about g of negative 6, guys? Still negative 6, okay? Because less than or equal to your x is your x is supposed to be greater than or equal to this n, but less than n plus 1. Clear, guys? Now, the last one, g of negative pi plus f of pi. What is this, guys? What is g of negative pi, guys? It is greatest integer of negative pi plus sine of pi. Okay, guys? So what's the answer for the first one? First term, guys?
-4.
Sorry?
-4.
Negative 4, because it is approximately negative 3.15, negative 3.1416, I think. No? So negative 4 plus 1, no? Am I right? So final answer is negative 3. Clear with this, guys? Number 4, given f of x equals 2 sine of x minus x. Find the following. F as a piecewise defined function. B, graph of f. Letter C, domain and range of f. So we know already sine of g of x, right, guys? What is sine of x, guys, in a piecewise form? It is negative 1. If x is to the left of 0, it is 0. If x is equal to 0, and it is 1. If x is to the right of 0, no? So our f of x, therefore, is given by 2 times. So 2 times negative 1. What is 2 times negative 1? Children? Negative 2, no? Minus x. If your x is to the left of 0. What about if x is equal to 0? 2 times 0. What is 2 times 0? 0. Minus x. Minus x. Okay? So it is, let me write that, 0 minus x. If x is equal to 0. Actually, we can simplify this now into simply 0 later. And then, what about 2 times 1 minus x? So 2 times 1 minus x is 2, then minus x. Okay? If x is to the right of 0. Is that clear, guys? Okay. What's the simplified form, children? What is the simplified form of this? So the middle is 0 because x is 0. So this is simply negative x minus 2. And this is negative x plus 2, no? The last one. The first one, if x is to the left of 0, if x is equal to 0, and then if x is to the right of 0. Okay, so this is our final answer. That is f of x. Any question with that, guys? What about the graph of f? Letter B. So this is letter A. So letter B, graph of f. Graph of f. So the graph consists of 1 point, 0, 0, and then 2 slant lines, no? Okay, guys? Are they connected, children? Guys, are they connected? Is the first one connected to the second one? Guys, it's not, no? Because if x is 0, this is -2. It's not connected to 0. If x is 0 here, it is +2. So they are not connected. So the graphs are not connected. One isolated point, meaning it's not connected to any, no? So we have y is equal to -x plus 2, minus 2 the first one. If x is less than 0, so I can assign values. When x is 0, although it's not part, so it is a whole later, -2, no? If x is -1, it is -1. Am I correct, guys? +1, -2, -1, no? What about for y equals -x plus 2? So that is for x greater than 0. I can start with 0 also. That is +2, although it's a whole. And then 1 greater than 0, 1. So we have +1. So again, 0, 0 is just a point. So let's now draw the graph. X-axis, y-axis. We have 1, 2, 3, 4. Then 1, 2, 3. 1, 2, 3. -1, -2, -3, -4. -4, -2, +2, +4. This is 2, this is -2. Okay? So the middle part here is 0, 0. So that is an isolated point. The other one, for the first one, 0, -2, 0, -2. But it is open, no? Clear, guys? Children? Open here. What about -1, -1? So I get it here. And then I will connect it to this hole, no? Guys? Okay, guys? So that's the graph. Okay? Now, it goes upward, no? I think it passes through this 0, -2. I mean, -2, 0. And then going upward without end. Am I clear with this, guys? What about the other one? Hole where, guys? It is a hole at 0, 2. And then passes through 1, 1 together with 2, 0, no? Okay, that's it. That's the graph. Any question, children, with the graph? Guys? So what's the domain, guys? What's the domain? Guys? What's the
All
domain?
real numbers.
All real numbers. What about the range? Anyone? What about the range? Look at the graph.
All real numbers din po.
Set of all real numbers, no? So it is what? Confusing, no? If you don't look at the graph very well, you won't say that it is set of real numbers, no? But you looking at it, it's really the set of all real numbers. Clear, guys? Any question? What about number 5? Guys, given f of x equals greatest integer of x minus 1, then minus x. So we want to know this f as a piecewise defined function and also the graph of f. I want the graph only from -2 to less than 4. And then the domain and range of f. Clear, guys? Guys. Okay. So let's now have greatest integer of x. How do we define greatest integer of x, guys? Piecewisely. And then, once you know already the graph of that, actually, you have to shift 1 unit to the what? To the right, no? Because it is x minus 1. Okay? You're not shifting, guys? Children. Guys. I think I still need space here. Yeah. Okay. Okay, guys. Let's start with the middle. When x is between 0 and 1, including 0, what's the value of this greatest integer, guys? Guys, what number am I going to input? Let's say 0.5. When x is 0.5, 0.5 minus 1, that is negative 0.5. That is a sample number. What do we get, guys? Negative 1. Am I correct, guys?
Yes po.
Negative 1. Actually, all you have to do is to find a pattern, no? And it is always an integer. If x is to the right of 1, including 1, to less than 2, what is the value? For instance, I assign x that is 1.5. 1.5 minus 1, it is 0.5, right? What's the value? What is the greatest integer of 0.5? It is 0. Very good. And then what if you have between 2, including 2, up to less than 3? What do you expect? It is what? 1, right? So see the pattern, guys? And then next is 2. Am I correct, guys?
Yes po.
This is when x is between 3 and positive 4, including 3, and so on. Okay, children? Let me... Yeah. And then here, what about here? Negative 1, what's the next? Negative 2, and then the pattern, negative 3. Am I correct, children? And so on. So this is if x is between negative 1 and 0, right? Including negative 1 here. If x is between negative 2 and negative 1, including negative 2. Would you please check to finalize our piecewise form of the given greatest integer of x minus 1? Okay, guys? Okay na, this? But we are not after this actually, no? What we are after, f of x, okay? So what is f of x? What about f of x, children? So I'm going to have this, okay? So what are the intervals that I'm going to have? 0 to 1, 1, 2, 3. I think I need one more here. Let's have an extra one so that a balance, no, up and down. -4. -4 if x is 1, 2, 3, 1, 2, 3. If x is between -3 and -2, including -3, and so on. Okay. Okay? Yeah. Let's have the first one, middle. So if your x is between 0 and 1, -1 minus x. So -1, all you have to do is to subtract x, no? From -1. -1 minus x. So this is if what? If x is between 0 and -1. 0 and 1. Okay? Including 0. Let's put first the intervals. If x is from -1 to less than to 0, then -2 from that number to less than -1, and then the last one, but actually this is not the last, so we have already the pattern after this, from -3 to less than -2. Okay, children? And so on. And so on. So this is -4 minus x, -3 minus x, -2 minus x. Then here, 0 minus x is -x, 1 minus x, 2 minus x. So this is if what? If x is between 3 and 4, including 4. Including 3. If x is between 2 and 3, including 2. If x is between 1 and 2, no? Including 1. Okay, guys? There's pattern naman, all right? And so on. Is this clear, children? So this is the piecewise defined function equivalent to the given function. Clear with this, children? Guys?
Yes po.
What about for the graph, no? For the graph, letter B. So this is letter A, no? Letter A, graph. What about letter A is what? Letter B is graph. So we want to draw the graph from -2 to less than 4 only. So this is our y-axis. This is our x-axis. Are you now excited with the graph? How the graph looks like? 1, 2, 3, 4, 5. So this is 5. This is 2. Okay. -1, -2, -3. So this is -3. +1, here, positive 1 here. Positive 2, negative 1, negative 2. Okay, children? So this is negative 3. Okay. Let's start with the first part from negative 2. So when x is negative 2, so where is it? Here, no? When x is negative 2, 3 minus negative 2. What is that, guys? 3 minus negative 2 is negative. What, guys?
5.
Negative 3 minus negative 2. Negative 3
1.
minus negative 2. Negative 1. Am I correct?
Opo.
Is it included? Yes, no? Right? When x is negative 2, negative 3 minus negative 2 is negative 1. Okay? It's included. What about when x is negative 1? When x is negative 1, negative 3 minus negative 1 is negative 2. Am I right? But it's not included. It's open. Is it clear, children? Guys?
Yes po.
Let me put this number here so that it will not disturb our graph. This is negative 3. This is negative 1. So the graph is somewhere here. Open here. Okay? And then it is a what? Horizontal, slant line. No? Yan. Okay? What about if x is between negative 1 and 0? When x is negative 1, it is included. It is negative 1. Correct, guys? What about if x is 0? Negative 2, but it is open. I think I got a wrong position. When x is negative 1, solid, somewhere here. And when x is 0, negative 2, open. Okay, children? What about the other one? When x is 0, we have negative 1, close here. And then when x is 1, negative 2 also, no? See the pattern, guys? You see now the pattern? Bet open here, no? Guys? Guys, you see now the pattern?
Slant po.
Slant also. Actually, mga parallel sila, no? Na mga slant na ganito. A series of these. I mean, a sequence, no? So here, I have here the next, no? Right? And then, I will go here, but open. Okay? And then I will put open home later. So here, and then open also here, no? Right? And then the last one, is it the last here? And then open here also. Am I correct, children? Guys? Boys? So open sa x is negative 4, positive 2, ay negative 2, no? Okay. That's it. Well, see the graph, guys? So this is 4, no? Up to 4. But 4 is not included, no? We want. So from negative 2 to less than 4. Is this clear now, guys? F on negative 2 to 4. Okay? So that's the graph of that. Any question, children? Guys?
None, sir.
What about the domain, guys? I don't have space anymore. I think I can put the domain here. What's the domain, guys? So letter C, just here. What's the domain, guys? Set of all real numbers, right? What about the range? Not looking at the graph, because we want to find the graph, the dominant range of F, not the graph of the B. no? We limit only the graph from -2 to less than 4, but we're looking for the domain of the whole. Okay? What's the range, guys? Greater than 2 up to what?
-1.
Up to -1. Including -1, right? Including -1. Okay. That's it. Any question with this, guys? So I think you had this in your Genma. I do not know if you had this in Genma. What about number 6? Or number 6, guys? I think operations on functions, no? So given f of x is equal to x plus 1 all over 2 minus x, g of x is equal to 4 minus x, we want to determine f minus g of x. How do we define difference of functions, guys? F of x plus minus g of x, no? Okay, f minus g of x is defined as f of x minus g of x. Okay, what is f of x? X plus 1 all over 2 minus x. G of x is 4 minus x. Let's combine into a single fraction. So denominator is 2 minus x, that's the LCD. So x plus 1, 2 minus x multiplied sa 4 minus x, we get what, guys? Guys. So minus what, guys? Minus of 8 minus, guys. Boys. Is it 6x plus x squared? Am I correct? Guys? Guys? Children? Question, guys? No question? Okay. So this is negative x squared. This is positive 7x minus 7. Okay? What about the denominator? 2 minus x. Or I can start with positive x squared. So x squared minus 7x plus 7, but all over x minus 2. You can have that also if you want. A question, children? Guys?
Bakit po in-square yung binomial na 4 minus x?
Di ba we get the LCD, we multiply it to 2 minus x?
Oh, sige po. Thank you.
Di ba 4 times 2 is 8. Then negative 4x, negative 2x, negative 6x. Then positive x squared, right? But preceded by negative. Therefore, everything will become what? Negative inside. So negative x squared, positive 6x plus x is 7x. 1 minus 8 is negative 7. Then I multiply both the numerator and denominator by negative so that I will start with positive. Multiply by negative, positive, negative, positive. Multiply by negative, positive x na. Then negative 2. Am I right? You can have this one if you want, or this one. Any of the two. Okay? What about letter B? What is letter B? There's another one in letter A, sorry. F over G. So this is quotient, no? What is the quotient of these two functions? Children? So that is F of X over G of X, right? And this is with the condition that G of X is not equal to 0. We can divide, but with that condition. So what is our F? X plus 1 all over X minus, 2 minus X. All over, we have 4 minus X. So what's the middle, guys, here? The middle fraction is this, no? Be sure your equal sign is at the middle of the fractional bar. So this is our f over g of x. And this is equal to x plus 1 all over 2 minus x times 1 over 4 minus x. And then finally, what is our f over g of x, guys? X plus 1 all over, guys, that is x squared plus negative 6x plus 8, okay? Or if you want, you can have in factored form. X plus 1 all over, I can start with positive x minus 4, then x minus 4, x minus 2. So they are just the same, no, guys? 2 minus x, 4 minus x, same as x minus 2, x minus 4. Clear, children? Guys? What about FG? How do we define product of functions? We multiply the function values, right? So meaning negative 2 plus 1 all over 2 minus negative 2, it is 2 plus 2 times 4 minus negative 2. So meaning 4 plus 2. And then we get negative 1/4 times 6, no? And what is this equal to, guys? Negative 3/2. Okay? So that's the value of FG of negative 2. What about letter C? Letter B, I mean. F circle G. How do we define F circle G of X, guys? Anyone? Guys, how do we
Nalagay po yung mga values ng F dun sa X ng G.
How do we define F circle G of X? So it is F of G of X, na? So meaning we are going to insert the value of G of X to the X of X, to the X of F, na? So I get now 4 minus X, so that is for X here, plus 1 all over 2 minus, so what is my X? 4 minus X. Okay? What is this equal to? Guys. So what is F circle G? Children. 5 minus X all over X plus negative 2. Am I right, guys? Boys.
Opo.
What about G circle F of X? G circle F of X. This time, we have G of F of X. So it's like our independent variable to the G is the F of X, no? So what is our F of X? Our F of X is equal to X minus, what is it again? X plus 1, no? X plus 1 all over 2 minus X. So what is our G of X? Guys, 4 minus X. So we're going to put this X plus 1 all over 2 minus X to this X of the G, no? So 4 minus, what is my X? X plus 1 all over 2 minus X. So if we get the LCD, combine it to have one single fraction. 4 times 2 is 8, right? 4 times negative X is negative 4X. Then minus X minus 1, right? Guys? It's, I think it's stopping. All over 2 minus X. Clear, guys? Am I right so far? So it is 7 minus 5x all over 2 minus x. Normally, we want our final answer is starting with positive x, no? So, or you can have it 5x minus 7 all over x minus 2. Okay? Multiply both the numerator and denominator by negative 1. Negative 1 over negative 1 means 1. So, you only change the form, but you don't change the value actually. A question, children. What about if you're asked of the domain? What are the domains of F circle G and G circle F? So what if you're asked of the domain of F circle G? Guys. So this is it, no? To get the domain of the G, F circle G, so it is the domain of the simplified F circle G intersection with the domain of the G. What is the domain of these guys? Children, what's the domain of the simplified set of all real numbers except 2, no? Yeah. Then intersection with the domain of the G. What's the domain of the G? Domain of this is set of real numbers. So where do they intersect? Here, okay? So this is the final answer. Okay, guys? What about if you're asked of the domain of G circle F? Children. So that is domain of simplified G circle F. Simplified G circle F. Intersection with what? So again, the domain of G circle F is equal to the domain of the simplified G circle F intersection with the domain of the F this time. Because what we inserted inside is what? Is the f of x, okay? So this is the set of all real numbers except x equals to intersection with, what's the domain of the f? I mean, sorry, the domain of the G. Okay, what's the intersection of the domain of the f, guys? What is the domain of the f? Sorry, what's the domain of the f? Set of all real numbers except 2 also, right? Am I correct, guys?
Yes po.
So they intersect at the same, so itself, no? So this is also the domain. Okay, that's it. Any question with that? Given f of x equals square root of x minus 4, g of x equals x squared plus 4, find the following: f circle g of x, g circle f of x, and the letter B domains of f circle g and g circle f. Okay? Letter A, f circle g of x. What do I get, guys? F of g of x. What is this equal to? I'm going to insert x squared plus 4 to the x of f. So it's square root of, what is my x? X squared plus 4, right? Then minus 4. This is equal to what? Square root of x squared. Am I right, guys? Guys. What is square root of x squared, guys? Guys.
X.
It's not x. It's absolute value of x. Because this square root of x squared is always positive. So if you just write x, what if x is negative? So it's not the same with this. If my x, let's say, is negative 4, I input here negative 4. So what is the square of negative 4? 16 plus 4, 20. Or 20 minus 4, because that is now the input here. So 20 minus 4 is 16. Square root is what? 4. So, but if your answer is x, so the answer is negative x. I mean negative 4, which is against or not the same with the output, which is expected to be 4. Okay? So it's absolute. So if your x is negative 4, so f circle g of negative 4 is still 4. Okay, guys? Is this clear, children?
Yes po.
What about, unless you know that x is negative, you write negative x, and if you know that your x is always positive, you write positive x. What is the domain? Let's write the domain na lang din ito. Domain. So letter B to. What's the domain? Guys? All set of real numbers, right? Guys? What about G circle F of X? That is G of F of X. What is this equal to? I'm going to input the radical here inside. Square root of x minus 4, quantity squared, plus 4. This is equal to, guys, x minus 4 plus 4. Am I correct, children? Guys. But what is the domain of G circle F of X? What's the domain?
Or real numbers.
No. Remember, the domain is what? The domain is domain of what? Domain of the simplified intersection with the domain of what? Of your F. What is the domain of F? 4 to positive infinity. What's now the domain? Finally, 4 to positive infinity. Clear, guys? Did you get this, guys? Why is it that not the set of all real numbers? Because initially, if my input is, if I remember, I'm going to plug in my x first to this square root. Imagine if I input negative number, this is what? Undefined. So it can no longer be entered. It can no longer enter what? The x of the g. Okay? But if your x is greater than or equal to 4, okay, this radical will be defined and it can enter the x of what? Of the g. Is that clear, children? Guys?
Yes.
Guys? Because you cannot enter in F negative values now. Because if x is negative, this is what? Undefined. You cannot enter negative values to the x of F. Clear? Take note, the domain of a piecewise function is the domain of the simplified intersection with the domain kung ano yung i-insert nyo. Okay? Last one, I think. Last one. Given f of 4 minus x is equal to x plus 1 all over 2 minus x, what is f of x? So take note that I cannot substitute x to my what? To here. Okay? Because what I am given, f of 4 minus x. So the technique is to what? Guys, what's the technique? Is to let what? Is to let 4 minus x to what? By a simple variable, okay? So that you will have simply f of a simple variable, okay? So let y, for instance, is equal to 4 minus x. Then, I now have f of what? F of y. But what is my x here? X is equal to 4 minus y. Am I correct, guys? Children? So what is my x, children? 4 minus y. Then plus 1. All over 2 minus 4 minus y. Okay? Is that clear? I'm solving for f of y. So I have in terms of y on the right side for the meantime. Then we now have 5 minus y all over y minus 2. Check it, guys. Is that correct, guys? Guys.
Yes po.
What is now my f of x? I can just change what? Change this y to x. Because I know now my simple function f of y. So 5 minus x all over x minus 2. I just want to express this f of y in terms of x. That's it. Okay, children? What about f of x minus 1 all over x plus 4? Since I know already f of x or f of y, I can easily now find this. Okay? So I can substitute it to the x of f or to the x to the y of f. You can choose anywhere between the two. Okay, guys? So what is my x here? My x here is x minus 1 all over x plus 4, no? So 5 minus x minus 1 all over x plus 4 all over x minus 1 all over x plus 4, that is my x, minus 2. Simplify. To simplify, we multiply both the numerator and denominator by x plus 4. Okay, of course, with the assumption that x is equal to negative 4. Okay, what's the answer? For the first term, we have 5x. Then 5 times 4 is 20. Then minus x minus plus 1. Correct, guys? Cancel, then minus x plus 1. What about the denominator? Cancelled out, getting x minus 1, then minus 2x minus 8. Get it, guys? Can you follow, guys?
Yes po.
So this is 4x plus 21. And then the last one, the denominator, negative x minus 9. Or you can have it, if you want, negative of x plus 9 all over 4x plus 21. You do not have to worry. I know the options, no? I know what options are. Okay? So again, negative. Let me put the negative closer. Negative. Any question, children?